Okay, in this video we're going to look at basic drive system diagnostics. One of the things that we get is we get a lot of warranty claims where it's not the component that's the problem, it's the fact that it's actually been misdiagnosed. For example, a car will come into the workshop with a broken timing belt, and it may well be that the diagnosis is that the timing belt has broken and that is the cause. It may well be that the engineer will look at the drive system and see that one or more of the components, usually the automatic tensioner, has failed, and again that becomes the focal point for the failure, i.e. The cause is the tensioner. Again, this can be a misdiagnosis. What we tend to want to do is look at the sequence of events that led to the failure. So is the belt the cause or a symptom? Is the tensioner the cause or the symptom? We usually find that both the belt and the tensioner are a symptom. And this is because of different installation procedures. All manufacturers will have their own setup procedure, and occasionally they will differ. For example, this is the tensioner from the Vauxhall range, and it's what we call a compact double eccentric tensioner, mainly because it's compact and mainly because it has a double eccentric. Most automatic tensioners will be of this type. The double eccentric comes from the first eccentric being where the bolt attaches the component to the vehicle. This allows the tensioner to rotate in and out of the belt. Once this comes into contact with the belt, then the internal eccentric will start to turn. The internal eccentric is what is connected to the spring mechanism that applies the load. Let's have a look at that in more detail as we just take this apart. So here we have the same tensioner. We can now remove the central part, which is the external eccentric, what we would call the adjuster arm. And we can see inside that we have an internal eccentric. So when the tensioner contacts the belt, the internal eccentric then starts to turn, which will operate the spring, which will give us the tension. So again, if we take this further down, we can see we have a normal bearing inside a sleeve, off centre, an internal sleeve with another internal. So that's the double eccentric compact tensioner. Very simple, very accurate in the way that it works. One of the problems is in terms of setting the tensioner. Although all the tensioners would appear to look the same, in terms of what we do is all we have to do is mount the tensioner and adjust it until the two pointers line up. That's where the biggest mistake can be made, because manufacturers don't always use the same protocol for setting the tensioner. For example, it may well be on certain engines, and on the Vauxhall engine, you have to turn this in an anti-clockwise direction. It may be in some engines, like the VWs, you turn it in a clockwise direction. Of course, one of the problems with turning the tensioner in an anti-clockwise direction, it's actually anti to what we normally would do. Our brain as an automotive engineer is programmed to tighten something in a clockwise direction. So it's very, very easy to put the Allen key into the adjuster and turn it in the wrong direction. Of course, it will rotate on the eccentric, it will come into contact with the belt, the tensioner will operate and the pointers will line up, but it will be 180 degrees out on the eccentric. So, if we look at one where we are going to always wind it in the right direction, which would be clockwise, such as the VW, this brings us another problem. Because although we wind this in a clockwise direction, if we go past with the pointer and we wind it back, we then wound it anti-clockwise. That causes the back plate to flick to the wrong side of the locator. So again, although the tensioner is in the correct position, the backplate again is in the wrong position. This will then lead to the cursor coming into contact with the end stop and breaking the end stop off and damaging the tensioner. The net result is that this is a faulty tensioner because it's broken, when actually it's because a simple setup procedure has been misdiagnosed. Okay, so how can we avoid such a situation? Obviously, one way of avoiding the situation is to always follow the manufacturer's recommended fitting data. As experienced mechanics, we tend to look at the data and say we don't need to do certain parts, not understanding why that part of the procedure is in there in the first place. So I would always recommend that the manufacturer's fitting information is followed precisely. I would also recommend that although we may have done the job several times before, that we always look at that data just to refresh the memory into which way the tensioner is set and how the tensioner should be set. One other issue is that with modern vehicles, the drive system, for the automatic tensioner to set the drive system correctly, then the drive system needs to be in a particular position. And this is achieved by the use of specialist tools to position and lock the crankshafts and the camshafts. Again, failure to use the correct tool can lead to the installation of the tensioner backplate not being correct, which can lead to failure. The majority of components that we get back that have got a failure mode are because the installation procedure has not been correctly followed. Okay, so even with a wealth of experience, mistakes can still be made. We would always then recommend that the manufacturer's fitting data is followed to the letter. This avoids any confusion in terms of what the mechanic thinks should be done and what actually should be done. Another issue that we come across on a regular basis is one where the mounting bolt is broken. The mounting bolt breaks, and this normally is attributed to the fact that it's had a flaw in the bolt. Very easy to diagnose in terms of whether the bolt has a flaw in it or not. But again, it's a misdiagnosis because what we find is that is mainly due to the fact that the torque setting has not been correctly applied. So here we have a number of components that we see back on a regular basis, on a weekly basis, where there is no manufacturing defect or problem with the actual component. It's just one of the fact that it's been misdiagnosed in terms of the failure mode.